Hey everyone, so today we'll be we will be proving this expression right here, a trigonometric expression which I would say is quite advanced. And yeah, this will make up to be a really good practice question for you all, and you should definitely try this for yourselves before watching this video. So over here we have left hand side, which we have to prove is equal to right hand side. One thing that a suggestion and a tip that I would like to give you is that you should always experiment with both sides. It actually helps you in a way, and today we'll explore how. So first things first, if there's a tan squared theta outside, that means it was essentially something like this: tan power 4 theta 1 plus sine theta 1 minus cos theta, right? And the reason is because we are multiplying. It's a basic law of indices. For example, a squared into b squared into b can be written as a square root of b, right? So a power 4 into b can be written as a squared square root of b. This is essentially just laws of indices that you are required to know. So yeah, it initially looked something like this, and the next step made it into this, right? So yeah, that is actually good to know, and I'll tell you why. So let's begin with starting to prove from the left hand side, because that's more convenient, since we can use a substitution sine theta over cos theta over here, and cos theta over sine theta over here. So yeah, let's start with that. So square root of sine theta over cos theta plus sine theta divided by cos theta over sine theta minus cos theta. So let's just take LCM real quick, right? So we have 1 over here, so this will be multiplied by cos theta. We have 1 over here, this will be multiplied by sine theta and sine theta. So let's just take our LCM, which will give us sine theta plus sine theta cos theta divided by cos theta, and I will add a division symbol instead of this line over here, so it's much more readable and understandable. So cos theta minus cos theta sine theta divided by sine theta, right? Okay, so there are multiple things that you can do here. What I would like to do first is I will take the reciprocal over here so we can easily multiply this, right? So let's just take the reciprocal sine theta, and also I also want to take common of this, but okay, I guess I'll do it in my next step. Sine theta plus sine theta cos theta divided by cos theta multiplied by sine theta over cos theta minus cos theta sine theta, right? Now I want to take sine theta common from here and cos theta common from here, and we know sine theta divided by cos theta is in fact tan theta, so we'll be writing that as well. So let's just write that real quick: tan theta into, now let's just take common over here as well, like we said, sine theta common 1 plus cos theta, and in the denominator we'll take cos theta as common, and 1 minus sine theta. All right, so we are essentially getting another sine theta over cos theta, which means this is a tan theta once again, so it will become tan squared theta 1 plus cos theta divided by 1 minus sine theta. All right, square root. Okay, so let's just compare this with our expression, and if you notice, we experimented it like this, right? So let's just compare it with this. And as you can see, we have a tan power 4 theta over here. Meanwhile, we have a tan squared theta over here. And we have a 1 plus cos theta over here. Meanwhile, we have a 1 plus sine theta over there, right? So yeah, that's concerning, isn't it? Now, here's the thing. A lot of candidates will give up upon this step, and they will think that they're doing it wrong, or it's simply impossible, or things like that. But one thing that you can always do to verify if your steps were correct is that you can substitute any random value of theta, let's suppose 7 degree, over here, and you will get the exact same answer, which means your working so far is accurate. So that's a little tip from me, and if you can try it for yourself, and this will in fact work. So what do we do now? Remember when I said you should experiment with this side? Well, that will help us. The reason why is because we know that we need a tan power 4 theta over here. Meanwhile, we have a tan squared theta. So what we can do is multiply and divide by tan squared theta, because that makes no difference, since this can essentially just cancel out if we are trying to reverse the working, right? So yeah, Now, why am I multiplying by tan squared theta? It's because this can make this into tan power 4 theta, and perhaps we can use this with the denominator into reshaping this to this right here, right? Does that make some sort of sense? This is actually something that you should be comfortable with in P3 if you want to be a top tier student. So yeah, I know it's a bit difficult, but then again, like I said, if you experiment with both sides, this idea will in fact come to your mind that you need to make this into a tan power 4 theta. So let's proceed and write this as, we will multiply this and this, right? So tan power 4 theta, 1 plus cos theta, and 1 minus sine theta over here. So we'll be multiplying this with tan squared theta right here. Fine. I just use the numerator tan squared theta into making this into tan power 4 theta. So what next? Now let's substitute sine squared theta over cos squared theta over here, right? So that will make our lives a lot more easier. And let me show how. Tan power 4 theta, 1 plus cos theta divided by 1 minus sine theta into sine squared theta over cos squared theta. Now what you're doing is essentially dividing this cos squared theta in the denominator, which means you can just take it back to the numerator, right? For example, if you have 1 divided by 1 by 2, what is this? This is basically 1 divided by 1 by 2, and the 2 comes to numerator, right? If you're comfortable with this method, which is exactly why I can bring cos squared theta into the numerator now, if you were unaware of that. So yeah, let's just bring that tan power 4 theta, 1 plus cos theta into cos squared theta divided by 1 minus sine theta into sine squared theta. Now we still don't have that form over there, right? But if you have a good grip in AS trigonometry, you'll realize is that this can be substituted as 1 minus sine squared theta, which can later be converted into 1 minus sine theta, 1 plus cos theta, right? 1 plus sine theta, my bad. And this can be converted into 1 minus cos squared theta, which will become 1 minus cos theta, 1 plus cos theta. And having these brackets is essential because we can do some cutting and then we can obtain this expression right here. All right, so this was the final piece of the puzzle which we needed to do. So let's just do it. I'll be writing this directly, by the way. I want to skip one step to make this make this video a bit shorter. So tan power 4 theta multiplied by 1 plus cos theta, and as we discussed, we will be bringing this along the way. So let me just write that real quick. 1 minus sine theta, 1 plus sine theta divided by 1 minus sine theta, and now I'll be bringing this. So 1 minus cos theta, 1 plus cos theta. All right, so now we can essentially cut out a lot of things. For example, this with this, this with this, and we are left with tan power 4 theta, 1 plus sine theta divided by 1 minus cos theta square root. So now we can just take this out again and we will get our final expression, tan squared theta square root of 1 plus sine theta divided by 1 minus cos theta. And that's how you prove this expression right here.